In this video, we're going to demonstrate how an attacker can compromise VDI. In order to do that, we've built a fake online payment system that's running in a VDI session. So what we see now is a bank teller or an endpoint user completing a wire transfer with this system. Now, unbeknownst to the teller, there's malware on this device. Perhaps it got in through phishing. You can see this over in this blue window, but of course this is for demo purposes only. The teller would not see this blue box. So as you can see, this malware is overlay malware, which operates by creating overlay screens that mimic the appearances of sign-on pages. Think James Bond, freezing security cameras. These overlay screens can actually be so identical that it's really hard to tell if they're real or fake. So when the attacker launches this malware, behind the scenes, what the malware is actually doing is taking a snapshot of the screen and displaying that as the overlay. So we can see the malware has successfully compromised the VDI session and the application. So James Bond, our cyber attacker, can now do whatever he wants with the real wire transfer, while the teller just sees this screen for transferring payment. Once the teller is back in control of his machine, he sees that a payment was initiated. Inspecting further, we see that a backdoor was injected inside the payment app via access the attacker gained from compromising the VDI session. A CNC session was established between the host session and the VDI session. So these logs are all visible for demo purposes. Of course, the teller would only see the session go back to normal without any awareness that he has been breached. So what's the takeaway? VDI is not an isolation solution. It does not isolate the remote sensitive resources from the device used by the user to access them. If you control the user's device, you control the VDI resources, just as seen here.